Hello, this is Frank Allen at Davis High School in Aldine School District. This is a video for Unit 4, Lewis Structures and Shapes quiz. This is a quiz that we've taken several weeks ago, so if this is a grade that you need to retake or take for the first time because you missed it, then this is the video that you need for that. Before we go any further, you are going to need a piece of paper to do some writing on, and you will need to open a tab, another tab on the internet, and bring up a periodic table. So I say again, pause the video, get some paper, something to write with, open a tab on the internet, bring up a periodic table so that you can go between the video and back to the periodic table. Now, we're covering two things, Lewis structures and shapes. Lewis structures are diagrams. Some guy named Lewis invented them many years ago. But they show us where electrons are in a molecule. They show us the electrons that are being used to bond. For example, if you have carbon and if you have oxygen, and these two form a molecule, carbon monoxide, the Lewis structure is going to look like this. What that means is they are sharing 3 pairs of electrons. This is 6 electrons. And they've also each got a pair of electrons that they are not sharing. We'll just say that they're sort of not doing anything with them. Now these are the valence electrons. The number of valence electrons in carbon is not the same as the total number of electrons in carbon. Carbon has 6 electrons, but it has 4 valence electrons. And these are the ones that are used in bonding. And these are the ones that show up on a Lewis structure. And these are equal to their group number. Carbon is therefore in group 4. Oxygen has 8 electrons. 6 of them are valence electrons. So these are the ones that are used in bonding. These are the ones that are found in Lewis structures. And these are the ones that are equal to the group number, which for carbon is 6. If you're not sure how we got the group number for carbon and for oxygen, stop the video. I said stop the video, go to the periodic table, make sure you understand where we're getting group 4 and group 6 from. Remember that we skip the transition metals when we're counting groups. 1, 2, skip, 3, 4, 5, 6, 7, 8. Now, Lewis structures. You will be given these 2 rules. You do not have to memorize them. Everybody wants 8 electrons, except hydrogen wants 2. And then you need to check the number of valence electrons, and the valence electrons equals the group number. Stop the video, write these 2 rules down so that you can use them when you're working practice problems. So using those 2 rules, all you have to do is be able to tell me if a Lewis structure is drawn correctly or not. So I give you the Lewis structure. You check the 2 rules. Octet, which is the 8 electrons, except hydrogen, and 2, the total number of valence electrons. That nitrogen has 8 electrons around it, 2, 4, 6, 8. Any bond that is touching the atom, this atom gets to say, those are my electrons. This atom gets to say, those are my electrons also. So they're sharing these 4 electrons. So this atom right here, this one individual atom, has 2, 4, 6, 8 electrons around it. This atom has 2, 4, 6, 8 electrons around it. So for this structure, that first rule checks. According to the first rule, this structure is drawn correctly. The second rule is it has to show the correct number of valence electrons. Nitrogen is in group 5, but there are 2 atoms So each atom contributes 5 electrons to the overall molecule. So therefore we must show 10. We can't show 8, we can't show 12, we have to show 10 exactly. 2, 4, 6, 8, 10, 12. So this is not. This Lewis structure is drawn incorrectly. Carbon dioxide. You have to follow the 2 rules. I will give you the rules. You do not have to write them down. They will be on the quiz. Does everything have an octet? That oxygen has an octet. Carbon has an octet. That oxygen does not have an octet, which is 8, 2, 4, 6. So according to the first rule, this is not drawn correctly. Carbon monoxide. Everybody wants an octet, and you have to check the number of valence electrons. That oxygen has 8. That oxygen has 8. Excuse me, that carbon has 8. So the first rule checks. Valence electrons. Carbon's in group 4, oxygen's in group 6. Therefore, we have to show 10 valence electrons. 2, 4, 6, 8, 10. Therefore, this structure is drawn correctly. Water. Everybody wants 8 except hydrogen wants 2. Check the valence electrons. Again, you have these rules written down for you. You simply have to follow them. Oxygen has 8. Hydrogen has 2. Hydrogen has 2. Hydrogen does not want 8. It doesn't want 4. It doesn't want 6. So according to the first rule, that's drawn correctly. Check the valence electrons. Hydrogen in group 1, but there are 2 hydrogen atoms. Oxygen's in group 6, so that's a total of 8 electrons. 2, 4, 6, 8. Therefore, yes, this Lewis structure is drawn correctly. So that's how you use those rules to determine Lewis structures. The second thing, you have to tell me shapes. To tell me the shape, you have to have the Lewis structure. The Lewis structure on paper is going to look like this. Sometimes you may see electrons like that. So instead of a line, you've seen 2 dots. Now, the shape that you see on paper is not necessarily the shape that you see in real life in space. In real life, these hydrogens are going to be coming out towards you and going behind the paper. So this is going to be 3-dimensional instead of 2-dimensional and flat like this. So this shape has a specific name that is derived from what it looks like in space, not derived from what it looks like on paper. These are the shapes: linear, bent, triplanar, tri-pyramid, and tetra. Linear, you will have either 2 atoms or you will have 2 outside atoms, and you won't have any electrons in the middle. Electrons are negative, and this is sort of the thing that you have to remember. Electrons are negative, and they will repel other electrons. So these electrons and these electrons are going to orient themselves so that they have as much elbow room from each other as possible. 180 degrees is the greatest angle possible. 2 outside atoms, no electrons in the middle. If you have electrons in the middle, like this one, then it changes the shape a little bit. So anything that looks like this, whether it's a double bond or a single bond, doesn't matter, and the electrons on the outside atoms don't matter. You're just looking at the number of outside atoms and are there any non-bonding electrons in the middle. Bent is going to be 2 outside atoms, but you have electrons in the middle. So this is what it looks like on paper, In space, your water molecule is actually going to look a little bit like this. These electrons are pushing these electrons down and away. And of course, these electrons are going to be across from each other. They'd be coming out of the paper and back behind the paper. So these electrons are all going to be oriented as far apart from each other as they possibly can be. Triplanar. This indicates the number of outside atoms. This is what it's going to look like on paper. This is what it's going to look like in real life. These electrons are going to push each other around until they're the greatest distance from each other that's possible. They can't get any closer, because if these get closer, or rather if these get further away, they'll be too close to these other ones. Planar means that it's flat. These atoms are neither above or below the carbon atom. Tripyramidal this is what it looks like on paper. 3 outside atoms. That's what tri means. You've got electrons in the middle. They're going to push these electrons down and away so that what you get is something like this. And this just means that this is coming out of the paper, this is going behind the paper, and this is even with the paper, so that it's going to look sort of like a pyramid. But it's the presence of the electrons in the middle that cause that. Tetra is just a prefix for 4, and that means you have 4 outside atoms. It looks like that on paper. In real life, it's going to look a little bit like tripyramid, except you've got an atom up here instead of a pair of electrons. You have to be able to look at a Lewis structure and tell me the shape. So you need to sort of memorize these a little bit. On the quiz, you have to give me the definition. That's it for this quiz. Study this, come in, retake the quiz, and we'll see you next time.